Hi everyone, this is Dr. Love here, and I hope everyone's doing well in this biostatistics journey. I wanted to create a very short video highlighting the major concepts and terms that we are going over this week. So in this case, I'm going to give you a quick overview of descriptive statistics and graphs. So let's get started. So the question that I have for you is, what are descriptive statistics? Well, when you look at the term, describe numbers. So by now you should have a working definition of what this is, and most researchers like to use these numbers to explain about the population of interest and the samples that we collect from the population. It's also a very quick and easy way to summarize the large amount of data, especially with the raw data sets that you're using this week and last week, and some of the national data set. It's hard to make sense of what they are. So the descriptive statistics allow you to summarize and show what the data is telling you. So how do we do this? We organize and summarize. So we try to tell a story behind the raw data that's there. And it's organized by tables and graphs. Most people are very visual, so doing it by tables and graphs is a really great idea. And what we use in these tables and graphs are central tendencies and variations. Well, this will depend on the type of variables that exist or collected in your raw data set. So if you go to the CDC website here, as you can see, there are different types of variables. By now, you should be well versed with nominal, ordinal, interval, and ratio. And this site gives you a really good overview of how it's divided. It's either qualitative or quantitative. Another way to see it is categorical versus continuous. So the different types of variables, as you can see, the nominal is disease status, ordinal is ovarian cancer, the stages of it. The interval is a date of birth. In other cases, temperature is another example of interval, and ratio is the results of the TB test. So there's a true zero involved with ratio. So going back to organizing and summarizing, like I said, it will depend on the type of variables that you have in your data set. So how do you summarize? Well, you use central tendencies called mean, median, and mode. And the spread of the variation depends on, like I said, your types of variable, but standard deviation, variance, range, and interquartile range as well. There are two sites that you can go to check out the definitions of all of them and when it is used. So I'll post this PowerPoint in the discussion section so you can take a look. So let's look at the graphs. So I'm going to quickly list some of the popular graphs that are used in public health. So bar graphs, histograms, stem and leaf, box whisker plot or box plots, line graphs, pie graphs, and scatter plots. So the CDC site that we looked at before, it has a very good example of some of the graphs. So I'll post the link, like I said, in the discussion section so you can take a in-depth look at these type of graphs. So let me give you an example here. So let's say the question is, which group has a higher body mass index? So you're given group 1 and group 2, and you're given these BMI or body mass indexes. Group 1 has 11 subjects, and it doesn't seem too much, but still, it's a lot of data to process in your brain really quickly. Group 2, similar, 11 participants, and altogether there are 22 subjects. So by looking at this data, you still can't tell which group has a higher body mass index. So this is when descriptive statistics come in handy. So as you can see, the mean of group 1 and group 2, the median mode, as well as the standard error. Well, standard error is a special term or special type of standard deviation that is used for samples. So you'll learn about this more later on from your textbook and some of my other postings. And as you can see, the different spreads that you see are the variance range. You see the minimum, maximum, the sum, which doesn't matter at this point, but the count is like sample size. So as you can see, it's 11 and 11, a total of 22 altogether. But like I said, this is hard to decipher for people who don't like numbers, or the table can be a bit too much. So we use graphs to portray descriptive statistics. In this case, the average of BMI group 1 and 2, 22 subjects, and as you can see, they have very similar BMIs with the standard error bars here to see what the spread is. So the next step is to do the inferential statistics, but we're not there yet. We're just describing the data to show what the raw data is telling you. So if you have any questions or if you want to get more information, check out my weekly guidance post for more details. Or if you have questions, please post them in Ask Your Instructor form, or you can always message me. I'll get back to you in the Blackboard in a flash. Well, by 48 hours. And if you don't hear from me by 48 hours, please send me an email again, just in case if the message didn't go through. So take it easy, take good care of yourself, and take some healthy breaks. I am here for you, so please hang in there, and I will see you in the course room. Take care, everyone. Bye.